Hello, today I want to talk about microcontroller pins and how you connect peripherals to them. Now in front of you here you can see several different types of eBlocks board. This is an eBlocks Arduino board, this is an ESP Lowlin light board, and this is a PIC micro board. And the idea behind eBlocks is you can quickly connect and disconnect peripherals, and these are 14-way fast connectors, so power and ground as well as the 8 bits of each port is there. And normally we present pins in collections of 8. For the PIC micro there's ports A, B, C, D and E. For the Lowlin there's A, B and C. And the Arduino is slightly different because the terminology in Arduino is slightly different. Now before you connect things, like for example a sensor or a motor that requires pulse width modulation, you need to be making sure that the pins you're connecting to have the capabilities. So let's see how that works in a more diagrammatic format. So if you look on the internet, you can find lovely diagrams like the two I've shown you here that show what the pin functionality is on, in this case, an ESP32 and an Arduino is. And these diagrams look great and they do convey a lot of meaning. They're quite easy to understand, but the quality of them is quite questionable. You don't always find the right information. They don't tell you the full story. They're not available for all of the chips that you want, like you won't find one for a PIC micro. They don't show the connections to the eBlocks prototyping system, and they don't allow any manipulation. Very often you want to manipulate the information on a pin whilst you're planning your project. So we need a better way than this to convey the information about what's on a particular device. And a spreadsheet is a really good way of doing this. So here you can see a spreadsheet that shows an Arduino Uno which has 28 pins. It shows the port and the bit connections, and then it shows the functions of each of the pins. Now all the port and bit connections you can see here can be used as standard digital and input and output pins, but they have some additional functions. So for example, the analog pins are only on port C, as you can see here. The communication pins are only on the ports you can see in blue. So that's the USART on D0 and D1. This is an SPI bus, and this is an I2C bus. Interrupts are fairly widely available. And if you want to control a motor using pulse width modulation, varying speed, then you have to be quite selective about which pins you can see here. And on the last column, we've got the Arduino reference. The Arduino talks about 19 separate pins. The first 13 are digital and the last 6 there are analog. Now the Arduino is a great physical package, and there are advantages and disadvantages of this simplified notification. Of course, it's fantastically low cost and it's brilliant. So that's the Arduino Uno. Let's have a look at what it's like for a 16F18877. Now this is a much more modern microcontroller than the Atmega, which the Arduino is based on. It's got 40 pins, and you can see the ports and bits there. The great thing about the PIC is you've got 4 full ports, A, B, C, D, and then you've got a few on port E as well. And it's really quite convenient sometimes to have those full ports. There's some power and ground, and the great thing about a PIC is that it has analog capability on every single I/O pin, which makes life very simple, particularly when you're laying out a PCB. The other thing it does is what's called remapping. So for all the communications pins, you can actually choose pretty much which pins you want them to come out on. There's some internal wizardry that remaps the pins from the circuit blocks inside the chip that do communications onto the pin you want. Interrupts are widely available, as you can see, and PWM pins are also remappable. Now Microchip has slightly more sophisticated pins which allow some comparison functions as well. But essentially, they're PWMs, and you can see that nearly every I/O pin, apart from port E in this case, has a PWM function. So again, it's very easy to use when you're prototyping, because you can choose which pin you want for analog, for comms, and whatever. So it's a really great chip. The ESP32 is similar. It allows remapping of the PWM and a lot of the comms, not onto all of the pins you can see here. So that's quite easy to use. Analog functions are a bit more limited, as you can see there. And the PWM isn't available on every pin either. Now, curiously, the ESP32 is a 32-bit processor. The PIC we saw was only an 8-bit processor. And so the input outputs are a little more complex. You can't use a full port there. You've probably got to use the input output pins individually rather than writing a number to a port and so on. And just like the Arduino, the ESP renumbers or renames the general purpose input output pins to make life easier in some circumstances. And we love the ESP because it's web ready and it's a really cheap device that has great potential. So let's just look at how we remap those pins in Flowcode. So let's look at how Flowcode handles this. This is a small program. I've got a I2C temperature and humidity sensor and a DC motor, and I've selected an Arduino Uno. If you click on the I2C temperature sensor, you can see that the connections are grayed out, so you have to use C4 and C5 for the communication. You can change that so that you're using software, in which case you can use any one of a number of pins, but the software performance is not quite as good as the hardware performance in your programming. Similarly for the DC motor, you can see that you choose a channel, and the channel is an internal piece of hardware, and the pin that comes out on is fixed by your choice. You have no choice there. Again, you can use software, but it's not quite as efficient. If we choose a different chip, so for example, let's go and have a look at the 16LF18877. And if we select the sensor again, here you can see that the comms lines are remapped to any one of a number of pins on the chip itself. So it's much more flexible in what you can do. There is a default, if you like, inside the chip, but you can make virtually any choice. Similarly for the DC motor, you can remap that to one of a number of output pins. So it's remapped internally, and you've still got full pulse width modulation. So just be conscious that when you're creating a system and you're choosing which ports and bits to put your sensors, motors, and other devices on, you need to be conscious of what the chip is capable of. Okay, thanks for watching.